Okay, so we continue where we left off. So we've solved the earlier part of this question, 3.1, 3.11, 3.21, and we're left with 3.35. Okay, so 3.35 in problem 3.11a, this one, find the conditional PMF of x, the maximum of coin tosses given that x is bigger than 0. Okay, so if we write the conditional probability, the probability of x taking some value given that x is bigger than 0. Okay, so we know that probability A given B is the probability of A intersect B divided by the probability of x is the probability of B, right? Okay, so the probability of x intersect with x is bigger than 0. So we have x equals to 1 given x is bigger than 0. Okay, so the probability is, what is the probability of x? Okay, so the outcome for x is 0, 1, and 2, right? Okay, so the probability of x intersect B, which is x is bigger than 0, two cases, okay, which is 1 and 2. Okay. So first we look at what is the probability of x is bigger than 0. Okay, probability x bigger than 0 is the probability of x equals to 1 plus the probability of x equals to 2, right? So 8 over 16 plus 7 over 16 gives you 15 over 16. So this is the probability of x bigger than 0. Okay. And the probability of x equals to 1 is 8 over 16. So 8 over 16 divided by 15 over 16 gives me 8 over 5. Similarly, x equals to 2 given that x is bigger than 0. Okay, so you have 7 over 16 divided by 15 over 16. So the possible outcome for this probability when conditioned on x is bigger than 0 is just 8 over 16 when k is 1 as well as when k is 2. So we don't consider k is 0 because it's conditioned on x is bigger than 0. Okay, right. Let's look at B. So B is asking that we find the conditional PMF of x given that Michael got one head, okay, in 2 tosses, right? Okay, so for B, maximum number of coin toss when Carlos and Michael each flip a pair coin twice. This is the original x, okay. And then given that, so this is the possible outcome for x, the maximum of coin tosses. This is what we did previously. Now we find condition on Michael got one head in 2 tosses. So for one head in 2 tosses, this is the outcome for Michael, right? One head. Okay, so we look at these are all the possible outcome when we condition on Michael obtaining one head. Okay, so the probability is we can get 1 or 2 as the maximum number. Okay, we cannot we don't have any other options. Yeah, there's no 0 because it's conditioned on Michael obtaining one head in these 2 tosses. So let's look at all the possible outcome for the case where we condition on this. So we can have x equals to 1 as well as x equals to 2. Okay. So what is the probability of this? Okay, so x equals to 1, comma, when n Michael means the number of heads for Michael's toss is equal to 1. Okay, and then divide by the probability of n m equals to 1. So we look at the probability of n m equals to 1. This one is equal to 1 over 2 times 1 over 4 plus 1 over 2 times 1 over 2 plus 1 over 2 times 1 over 4. Right? This is the outcome. This one is equal to 1 over 2 times 1 because all this add up to 1. Okay? And then for x equals to 1, comma, and m equals to 1, these are all the possible outcome. X equals to 1, and this one Okay, and this one, so you have 1 over 4 times 1 over 2 plus 1 over 2 times 1 over 2. Okay, this one. In this case, is only this and this, right? And when x equals to 2, given that Michael's toss is 1 head, you only have this as your possible outcome. So this one is 1 over 2 times 1 over 4. Okay, divide by the probability of Michael gets one number of heads is 1 over 2. So you have this. So all the probabilities condition on number of Michael is 1. So you have just these two outcomes. Okay. Okay, so the next one is D in problem 3.11b. Find the probability that Carlos got the maximum given that x is 2. Okay. Okay, so the next one is, sorry, 3.35c. Okay, we haven't done C yet. Find the conditional PMF of X given that Michael got one head in the first toss. Okay, so Michael tosses the coin twice. Okay, now we are looking at the first toss and the second toss, right? Okay, so we changed the a little bit this diagram that we had just now. Okay, instead of looking at the X as the number of number of heads, okay, we label as the first toss and the second toss. Okay, like this, 0 0. This is 0 head on the first toss, 0 head on the second toss, 0 head on the first toss, 1 head on the second toss. Okay, so that's how you read this. Okay, so 0 is tail, head gives is 1. Okay, so here is 2 heads, right? Okay, so we change this into something like this because the experiment wants to know the probability, uh, okay, the conditional PMF of X given that Michael got one head in the first toss. Okay, so if you look at the content of this table, it's only been filled up by these last two rows because this is the case where Michael gets the head on the first toss, either head and then tail or head and then head. Okay, so we look at all this combination because it's conditioned on this happening. Okay, so with this, this we tabulate with the maximum number of heads. Okay, so here no heads, one head, so one is the maximum. This is also one. This is also one, and this is two, but one here. So this is two is the maximum. Okay. So condition on this, these are all the possible outcomes for this condition. Okay, so we can have a probability of x equals to 1. So we have 1, 2, 3. So it's 1 over 4 times 1 over 4 times 3. So we have 3 over 16. Divide by what is the probability of Michael obtaining 1, 0 as well as 1, 1. So you have 1 over 4 plus 1 over 4. Okay. So here you have 3 over 16 divide 1 over 2. And for x equals to 2, you have 1, 2, 3, 4, 5. Okay. So 5 over 16 divide by 1 over 2. For 3.35D, okay, in problem 3.11B, in 3.11B, we see the situation whereby Carlos has a biased coin. The probability of getting head is higher, which is 3 over 4. And for this case, we are asked to find the probability that Carlos got the maximum given that x is equal to 2. Okay, meaning that Carlos gets both heads. Okay, so what is the probability that Carlos gets 2 given that x is equal to 2? X is the maximum. So the maximum, x is the maximum number of heads in those combination. So the maximum is 2, 2, 2 here as well as 2, 2 here, right? So what these are all our outcomes when it's conditioned on x equals to 2. So the number of Carlos getting 2 heads, the outcome is limited to this case, right? Okay, so you find the probability of this situation. So you have 1 over 4 plus 1 over 2 plus 1 over 4 times 9 over 16. Okay, divide by the probability x equals to 2, you have to add all the probabilities that gives you this. Okay, so we have all this, right? Okay, so this is 1 over 4 times 9 over 16, 1 over 2 times 9 over 16 plus 1 over 4 times 9 over 16 plus 2, 1 over 4 times 6 over 16 and 1 over 4 times 1 over 16. Okay, so this is all that. Right, and then this solving this gives me 36 over 43.